ARIMA in machine learning. AI intermediate level. Introduction. Many real-world datasets involve time-based data, where values are recorded sequentially over time. Examples include daily stock prices, monthly sales data, hourly electricity consumption, yearly population growth. Predicting future values from such data is called time series forecasting. One of the most widely used statistical models for time series forecasting is ARIMA. ARIMA stands for AutoRegressive Integrated Moving Average. It is a powerful model that analyzes patterns in historical data and uses them to forecast future values. ARIMA is commonly used in industries such as finance, retail demand forecasting, energy consumption prediction, weather forecasting, economic analysis. Understanding ARIMA helps learners build predictive models for time-based data. What is ARIMA? ARIMA, AutoRegressive Integrated Moving Average, is a statistical model used for forecasting time series data. In simple words, ARIMA equals a model that predicts future values based on past observations and past prediction errors. Example concept. Past observations means ARIMA model means future forecast. ARIMA models use patterns in historical data to estimate future trends. Components of ARIMA. ARIMA consists of three components. AR, autoregression. I, integration. MA, moving average. These components describe how the model analyzes time series data. Autoregression. AR. The autoregression component uses previous values in the time series to predict future values. Example concept. Previous values means predict next value. For example, today's stock price may depend on yesterday's price. Today's temperature may depend on yesterday's temperature. The AR part captures relationships between past observations. Integration. I. The integration component is used to make the time series stationary. Stationary data has constant mean, constant variance, stable patterns over time. Example concept. Original time series means differencing means stationary data. This is usually done using differencing, where consecutive values are subtracted. Moving average. MA. The moving average component models the relationship between observations and past forecast errors. Example concept. Past prediction errors means improve future predictions. This helps the model adjust predictions based on previous mistakes. ARIMA parameters. ARIMA models are described using three parameters. ARIMA, P, D, Q, where, parameter meaning, P number of autoregressive terms, D number of differencing operations, Q number of moving average terms. Example concept. ARIMA, 2, 1, 1. This means 2 autoregressive terms, 1 differencing step, 1 moving average term. Selecting appropriate parameters is important for model accuracy. Stationarity in ARIMA. ARIMA models require stationary time series data. Example concept. Non-stationary data means differencing means stationary data. Stationary data has stable statistical properties over time. Common methods to check stationarity include augmented Dickey-Fuller test, visual inspection of time series plots. ARIMA workflow. A typical ARIMA workflow looks like this. Time series dataset, down pointing arrow, check stationarity, down pointing arrow, apply differencing if necessary, down pointing arrow, select ARIMA parameters, down pointing arrow, train ARIMA model, down pointing arrow, forecast future values. This process allows the model to capture temporal patterns. ARIMA versus other time series models. ARIMA is often compared with other forecasting models. Model description. ARIMA statistical time series forecasting. Profit handles strong seasonality easily. LSTM deep learning model for sequential data. Example concept: statistical forecasting versus deep learning forecasting. ARIMA works well for traditional time series forecasting problems. Advantages of ARIMA. ARIMA offers several benefits. Advantages include strong statistical foundation, effective for small datasets, interpretable model parameters, good performance for linear time series patterns. Example concept: historical patterns means reliable forecasts. These benefits make ARIMA a popular forecasting model. Limitations of ARIMA. Despite its usefulness, ARIMA has some limitations. Limitations include: assumes linear relationships, struggles with complex nonlinear patterns, requires stationary data, parameter tuning can be difficult. Example concept: complex patterns means ARIMA limitations. In such cases, machine learning or deep learning models may perform better. Example Python code. ARIMA can be implemented using Python libraries. Import ARIMA model from statsmodels.saw. ARIMA model import ARIMA. Train ARIMA model. Model equals ARIMA. Data order equals 1, 1, 1. Model underscore fit equals model.fit. Generate forecast. Forecast equals model underscore fit. Forecast. Steps equals 10. These tools allow developers to build forecasting models easily. Real-world applications. ARIMA is widely used in real-world forecasting systems. Finance. Stock price forecasting. Retail. Sales demand prediction. Energy. Electricity consumption forecasting. Weather. Temperature forecasting. Economics. Economic indicator predictions. Concepts learned from ARIMA. Understanding ARIMA helps learners understand. Checkmark how statistical models forecast time series data. Checkmark how past observations influence future predictions. Checkmark how stationarity affects time series modeling. Checkmark how ARIMA parameters control model behavior. Checkmark how time series forecasting works in real-world systems. ARIMA is one of the most important models in time series forecasting and statistical machine learning. Simple definition. ARIMA, AutoRegressive Integrated Moving Average, a statistical time series forecasting model that predicts future values using past observations and past prediction errors. Final summary. ARIMA is a widely used statistical model for time series forecasting. By combining autoregression, differencing, and moving average components, ARIMA models capture patterns in historical data and generate future predictions. Although newer machine learning and deep learning models are increasingly popular, ARIMA remains an important technique for understanding and forecasting time-based data. Learning ARIMA is essential for working with time series analysis and predictive modeling in artificial intelligence.